Prior-free optimal mechanism design. In the previous sections, a number of results on approximating the optimal mechanism in worst-case settings were presented. Unfortunately, these results remain limited in their applicability. For example, what if OPT Q of B is too small, as might happen if the size of the market, i.e. the number of bidders, is too small? In such cases, Theorem 13.30 may give us no guarantee. Thus, a natural question to ask is, what is the best truthful mechanism? Can we design a truthful mechanism for which we can prove non-trivial performance guarantees under any market conditions? The first observation that must be made is that there is no such thing as an absolute best truthful auction. To gain some intuition for this statement, recall that in any truthful auction, the offer price Ti to bidder I is a function of all other bids B minus I, but not of Bi. Thus, given any particular auction which is forced to fix the offer price Ti, independently of Bi, and hence always performs suboptimally for most values of Bi, there is always some input on which a different truthful auction performs better. See exercise 13.8. Given that there is no absolute best truthful mechanism on all inputs, we are left with the question of how we can arrive at a rigorous theoretical framework in which we can compare auctions and determine one to be better. The key to resolving this issue is in moving from absolute optimality to relative optimality. Indeed, whenever there is an information theoretic obstacle or computational intractability preventing an absolute optimal solution to a problem we can try to approximate. For example, in the design of online algorithms, the objective is to find an online algorithm that performs comparably to an optimal offline algorithm. The notable analogy here is between the game theoretical constraint that a mechanism does not know the true bid values in advance and must solicit them in a truth-inducing manner, and the online constraint that an online algorithm does not have knowledge of the future. Competitive framework. The general approach will be to try to design an auction with profit that is always, in worst case, within a small constant factor of some profit benchmark. Definition 13.32. A profit benchmark is a function g which maps from R to the n to R, which maps a vector of valuations to a target profit. The following definition captures the intuition that an auction is good if it is always close to a reasonable profit benchmark. Definition 13.33. The competitive ratio of auction A, defined with respect to an implicit profit benchmark G, is beta equals the superior of G of B over G of B, where the superior is taken among all possible B. Given a profit benchmark G, the task of an auction designer is to design an auction that achieves the minimum possible competitive ratio. This auction is the optimal competitive auction for G.